So if you can summarize last week's summary from last week. Okay, so what we've looked at is, let's say we know that f is continuous. Let's say the function f is continuous in interval a, b. Okay, and then let's define big F of x. Let's define that as that function f, okay, evaluated at the integral from a to x. Okay, so and then the first result that we got from that is actually the first fundamental theorem of calculus, which is if you integrate that function f, okay, and then you differentiate that integral, this will become fx again. Okay, so as you can see, I'm just writing it down, whatever's inside that, because integral is antiderivative, so that means if we differentiate antiderivative, we'll get the same thing again. And then the second result that we can get from last week was that, well, if you know this, that means the integral of f of x is big F of x. Then whenever you try to evaluate a determinate integral, what you'll get is basically this. Okay, all right. And I think it's obvious from here that, you know, if you have something like you integrate something from a to a, okay, the result will be 0. I think it's apparent from that. Yeah. Okay, so that was what we've learned last week, and also we've learned about what we call a Riemann sum. The reason I say this because this will has some applications in computer programming, for example, in your later courses, and also it helps us to understand what is actually, finding the area under the curve using rectangles, trapezoid, whatever shapes that you think is easier to find the area of. Okay, so that was last week. So this week, let's take a look at our rules of integration here. Okay, let me repost that here. Okay, let me repost this here. All right, make it smaller, I guess, or make it bigger because some of the writing is small. Okay, so this was last week, so if you need time to write that down, you could. Okay, and then we look at this one here. So this is what we're going to do today. The way I'm going to do this is basically by just giving you examples. Okay, so we look at it one by one. I think that's hopefully you can get more understanding on it. Okay, so let's I think you have done integration before, probably in your high school math, or maybe in your technical mathematics, or any pre-university courses on math. But I don't need to go to basics too much, but I think you've always see this, yeah? C is a constant. If you integrate something with the indeterminate integral, you always see this around, plus c. Okay, so what is it actually about, plus c? Okay, so let me show you this. Let's say you let's say f of x is, for example, a number, a constant. Let's say it's 6. Okay, so what if you differentiate f of x? What will happen? you're basically differentiating a constant, which will make it 0. Okay, and then we've learned before that if integral is like antiderivative. You're trying to find if you integrate this, okay, you'll get this 6. Okay, so that's why sometimes in the zero rule, not sometimes, in the zero rule, if you integrate something that is 0, you'll get a constant. You don't know what this number is. Okay, so because it's imagine if you have another function f of x equals to 391, for example. When you differentiate that, you're gonna get 0 too. Okay, so that's why whenever we integrate 0, you'll always get a constant. Constant here meaning it's referring to this number here. We don't know what number that is, but we know it's differentiating a constant. That's why you get 0. So when you integrate a 0, you'll get some constant. So that explains a bit about the zero rule, and that is why when we integrate a constant, for example, well, we know, let's say for example, we know, let's say given the function of x is x, and then from this d dx of x is 1. All right, and that was the reason why you can see if I integrate 1, for example, respect to dx, you'll get x, but I always add the plus c here. The reason is, here we just leave it as an unknown c, because let me show you an example. Let's say f of x is given x plus 6. If you differentiate this, what are you gonna get? You're gonna get 1 too. Okay, so that's why when you integrate this number, you're gonna get something like here. Okay, but in this case, because we don't know the original function, we're trying to find this. Okay, so we always add c here. All right, it's just the difference is c here is 0 and c here is, the constant here is 6. Okay, so that's the reason why we always have to put the plus c, because we don't know, there might be a constant there. It could be 0, it could be 1, it could be some numbers, real numbers, but we don't know what it is, but we know it's a constant. So that's why you always have to plus c in there. So this 3 rule here, okay, this one, and this one is pretty easy. Okay, so that's pretty straightforward. Now I think one of the most common functions that we're going to deal with in engineering is the polynomial functions, and there will be some cases where we have to integrate polynomials. So that's why we introduced this power rule here. Okay, so power rule is simple. Okay, let me write down here. Power rule is really simple. So if you have, let's say, f of x equals to x cubed, and then let's say you're trying to find the integral of x cubed with respect to dx. Okay, so using that here just now, let me wait a second, what am I doing? No, I think this is what I'm going to do. I'm going to I'm going to put this here, power rule. Maybe put this here. Okay, let's move this here, and let's this. Okay, so according to that, what's going to happen is, if you integrate that, then the answer is going to be sometimes this OneNote is not operating with me. Come on, what are you doing? Why is it not? Wait, hold on, I'm having some problem with my pen here. Wait, okay. Alright, cool. So that would be x3 plus 1 divided by 3 plus 1 down here, and add a constant. So that would be x to the power 4 divided by 4 plus c. Let's check. So one way to check is, let's say we differentiate x to the power 4 divided by 4 plus c. What's going to happen is this is going to be 4 and then x cubed divided by 4 plus a constant. Well, if you differentiate constant, you get 0, so plus 0, and you'll get x cubed. There you go, you get that back. So that's one way to check. Okay, I guess this is pretty simple, all you need to do, but let's try something weird a bit. Okay, let's put some constant at front. Let's put 2x squared. What are you gonna get? X squared with respect to the x. Okay, so according to this rule here, this one, constant rule, if you have a constant in front of function, for example, you can bring it out. Okay, so you can always say this is equivalent to that, and you can do your work there. So x plus 3, so what you're gonna get is x over 3 and divided by 3. So your answer would be 2 over 3 x, oh, don't forget the plus c cube plus constant. Okay, you can try to differentiate this one, see if you can get this one. Okay, so those are the easier parts. Let's pick this. I guess this is all too easy. I guess sum rule. Sum rule is simple. Let's say okay, sum rule is simple. Let's say you have a summation of function. Yeah. Let's say you have example. You have fx equals to x squared, and then you have another gx equals to x, for example, or you have, let's add one more, hx equals to, let's say, 1. Okay, and then try to find this x squared plus x plus 1 with respect to d of x. Okay, what is it going to be? So whenever you see this, what you're going to do is just separate them all. Okay, you can do this, separate them. Okay, here you will get this one, x cube 3 plus this one would be, what is it, x 2 by 2, and what about that one? Let's see. Oh, what about the c? Should we put c plus c plus c? No, we don't have to do that. We can just assume c1, c2, c3 are all same constant, so we can just put one c here. You can just put like that. Okay, so it's simple. Any questions so far? Let me know, because I've been going on and on for 15 minutes. I don't want to be talking alone here. Okay, yeah, Zif, thanks. Alright, how many people do you have today? It's quite a lot. It's okay. Alright, so those are simple ones. I guess I think those are enough, but let's do the hard ones. Okay, the harder ones to kind of understand is all this. Okay, but I want to concentrate on this one, integration by parts. You're gonna see a lot of this in well, when exam questions, yeah. Usually questions really like to ask you these type of questions because I think it's because it's testing your technique of integration, whether you understand what you're doing or not. Okay, so let's do that again. So I think another form that you might be familiar with when integration by part is this one. I think you're probably familiar with this one, u dv equivalent to u v minus v dv, v du, sorry. Okay, I think you probably might be familiar with this. It's quite it's the same thing. All right. So let's try and do little by little. Let's take, first and foremost, I think I would like to take an example from the book. Let me find this. Wait a second. I think this one is okay. I'm just going to copy this. Okay. All right. All right. Just put a solution first, and then we're going to figure out what's on it. Okay. So this is an example. What was the question? X squared cosine x. Okay. So example is x squared cosine x. So you need to find x squared cosine x dx. Okay. How are you going to do that? Using this integration by parts method. All right. So let's see the solution. Let me make it bigger so that you can see it better. All right. So now we've got a problem where the form of the function is not as simple as what we've seen before. You know, it's not like a polynomial, easy polynomial. It's not really a constant. Okay. So what do we do with this? How to find how to integrate this function using integration by parts method. Okay. So now what it's doing is it's setting up this part here, x squared as u. All right. And then it's setting up this part here, okay, as dv dx. Okay. All right. So that it means that let me rewrite that down. So what you're gonna have is you're gonna have this form right now, u dv. Okay. Right. Because this is dv dx, and then you got another dx here. Okay, here. All right. So you can just write it down. You can simplify to u dv. So that's what it's doing. It's transforming this messy little function here into this form. Okay. And then by using this formula, you can see that this is the answer. So whatever the integral will be, u v minus the integral of v respect to du. So now what you need to do is just you substitute everything. Okay, so you know that u here is x squared, just like you decide here, x squared And since dv dx is cosine x, v is sine x, right? If you differentiate this, you're gonna get this, correct? See what it's doing here? All right, so x squared, so you just write down what v is here, sine x. So that part is done. Now we need to do that part, this part. Okay, so what is v in this case? It's sine x, so you need to integrate sine x with respect to du. In this case, what is du? So since u is 2x squared, so du dx is 2x, and du will be 2x times dx. So v here is this, and du here is 2x dx. Okay, now you've got x squared sine x minus 2, we bring it out, and then x, we leave it inside. Now that is done, but here we have another problem where you have to differentiate, integrate by parts again for this part here. Okay, so let's see the solution. How does it? What I've done is I've done from here to here. Okay, so I'm trying to convert this here into something that is more manageable. So I've done the u v minus v, my v du here. I got this, so now I got this answer here. But now the problem is here, I need to redo that again. So we now apply the same technique to the last integral. So now I need to do this sine x dx. Okay, so again, let's apply integration by parts again. Okay, so I'm setting this as u and setting this as dv dx, and then I can use this method here, what was it again? U dv is equivalent to u v minus integral of v du. All right, so since u is x, so I can just write down x. What is v? Because v is dv, because dv dx is sine x, so that means v is minus cosine x. I know that, so I can just write down here minus cosine x minus v in this case is minus, so plus cosine x dx. So this one is easy. What I've got is, oops, I don't think you could see it. Okay, there you go. Plus sine x plus constant. Okay, just like this one. Okay, so if substitute back in here in the original one, okay, you'll get this original, what we've done before. Sorry. So this is what we've done before. Okay, and then I think we've got this is what we are doing now. Okay, add them all up together, you can get this answer. So that's actually a hard example. Okay, let me show you another example of integration by parts. Integration by parts. Let's see. I think this one is a bit more. Let's again copy down the solution, and then let's try to rework that solution. Usually this is how I learn. Example, in this case, fx given is x natural log of x. Okay, so what is, alright, so this is the solution. Okay, it's much simpler than before. You don't need to do twice. So what I need to do here is I need to follow my integration by parts rule, integration by parts, which is uv minus wait, so this is the answer. Integral of u dv is equivalent to uv minus v du. Okay, so I need to first step is always need to set up what is u and what is v. So in this case, I'm setting up x, natural log of x. Okay, so I'm setting up this as u and this one as dv dx. It's easier that way. All right, so in this case, if u is natural log of x, I know that du dx is 1 over x. Okay, and then this one here, if dv dx is x, so v is, I know it will be x squared divided by 2. Okay, because if I you know, you can see that straight away. All right, so I know all this now. I know this, so I can just plug in whatever inside here. So let's plug it in. What is u? U is natural log of x. What is v? V is x squared over 2. Okay, minus integral of v. V is in this case x squared over 2, and du in this case is, so du is 1 over x dx. I'm just moving this dx to the here. So what I've got here is multiplied by 1x dx. Okay, cancel this out. I got x over 2. So I can rewrite everything again. Minus x over 2 dx. So this is basically a constant, so I can just bring this out here, half. All right, and then find the integral of this. That one is easy, so rewrite everything again. X squared 2 minus this can become x squared over 2, okay, plus c, don't forget the constant. So that is my final answer. Okay, let's see if it's the same as what is done here. Oh yeah, it's the same. All right, you can see that. All right, do you want more examples? Yes. Okay, all right, let's do one more example of integration by parts. Okay, in this case, let's pick something, let's say find the integral of x squared e minus x dx. Oh, before that, you need to know, yeah, if I integrate this, I will get this back again. All right, if I integrate, probably you have seen this before, you can get that. All right, okay, there's just some side tracking. So let's do this using integration by parts. Integration by parts, remember, u dv, integration of u respect to dv, you will get u times v minus integration of v respect to du. Okay, so right now what we need to do is basically decide what is u and what is dv dx. Okay, and in this case I want this to be u, and I want, what is this? I want this to be my dv dx. Okay, so u is x squared in this case, and this one I want this. Okay, so now I need to find du dx. What is it? It's simple, it's just 2x. And if dv over dx is e to the power of minus x, so what is v in this case? I hope you're really good in your technical differentiation, so this will just become minus e x. If you don't believe me, you can just differentiate this again and you'll get this answer. Okay, so now, okay, I've got these four things. I've got u dv dx, and I know du dx and v. So now I can just apply this formula here. I can say that x squared ex dx is equivalent to just uv minus v du. Let's rewrite that. So u in this case is x squared, v is this, minus integral of what is v? What is v? Oh, v is here. So minus plus integral of x, and du dx is u 2x, so 2x and dx. Something's in my nose. So now I guess we encounter a problem where we need to do integration by parts twice, because right now we have this one here. Okay, so let's try and find the answer to do integration by parts for this one. All right, so let's find this one pula. Okay, 2x dx. Let me simplify everything so that it will become x e to the power of x. Okay, so in here I will decide that u would be something and d with dx will be something. All right, in this case u, I want to take this one x, and then this one is pick that one. So du dx in this case is simple, it's just that v is the same as before this one, which is actually minus e minus x. All right, so let's do this. X squared, oh sorry, what is it? What's this? So 2x e to the power minus x dx is just I need to put 2 here, uv minus v du. U in this case is x, v is that, minus integral of v, which is integral of v plus e minus x, and du dx is just 1, so I just leave it like that. Okay, and all right, I think if you integrate this, because integrate this, you can get minus e6 over again. So what I got here is minus 2x e to the power of x, and that's one, if we integrate that, you'll get e minus x, but don't forget the 2, so that's 2 here. So That is, don't forget the constant. Phew. All right. So now we got this for up here, and then we need to add it. So the answer to that would be, so the answer of our original question just now would be x minus x squared e to the power minus x minus 2x e to the power minus x minus 2e to the power minus x plus a constant. So there you go. It's kind of messy, but that's the reason is because we've done the integration by parts twice. Okay. Let's do another example. More examples is better. Let's do a simple one. This one. That one is quite lengthy. Let's do this. Okay. So let's try to find this. Again, we do the same thing because the formula is, if you need to integrate u dv, this will be equivalent to u times v minus v du. Alright, so we need to decide what is u and what is dx. Okay, in this case, let's let's do sine x, and dv is e to the power of x. Okay, so in this case, you know that du dx is cosine x, easy, and v in this case is just ex again. So let's solve this. You know that so you know e to the power of x sine x dx will be equivalent to uv minus v du. So what is u here? Sine x. What is v here? E to the power of x minus, what is this? V in this case e to the power minus x, and what's that? Cosine x dx. Oh man, actually this is you need to do this again with the same results. Okay, so for the later integrals, okay, hold on a moment. There's some trick here. So now it becomes messy like before. Oops. Okay, so now you need to take care of this plug. Okay, you need to take care of this. So how do we take care of that? Again, you need to use this integration by parts minus v du. We need to decide the u in this case and the dv dx in this case. Okay. Hold on a moment, I got problem with my screen. It's not showing up. Wait, I think I need to change my monitor. There you go. Alright, so in this case, let's pick again. I'm going to pick u as cosine x. I'm taking this one right here, and v is ex. So again, du dx is minus sine x, and v is of course e to the power of x. Alright, so we need to calculate now ex cosine x. I'm bringing this here. Alright, so according to this, u times v du. So u, I know that it's cosine x. V, I know that it's e to the power of x. Now I need to minus v e to the power of x, and then du, which is minus sign, so I got minus sign there. If you notice this, okay, if you notice this here is the same as this here. Can you see that? All right. So I can just substitute that again. Okay, can substitute that again. So let's write the original one. Original one is e to the power of x sine x dx. So what I'm getting here is e here, this one, e to the power of x sine x, all right, minus what I've got here. So that one is e to the power of x cosine x plus integral of e sine x dx. Okay, and then what I can do is here, that's 2 e x sine x, okay, dx is equivalent to e of x sine x minus cosine of x. Oops, I forgot to put c here. I forgot to put c here. Okay, c. So do you see what I'm doing? I'm just bringing this here and then combine it with this. I'm bringing it all the way there. So it becomes 2 of that equals to this minus this. Okay, and plus the constant. So now what I need to do is just, I know that this sine x dx is equivalent to, bring the 2 up here. This is quite tricky. I like this question. Okay, plus constant. There you go. Oh, that was a hard one. But interesting. I need to do some tricks to get the answer. That's an adventure. I like this question. Maybe I will ask this in the exam. I thought I was stuck just now. Alright. It's kind of daunting to do it in front of you. Okay, but yeah, we managed to do it. I did some trick. What I'm doing is basically like this. Let me just go through again what I'm doing. So the problem is we need to find this right here. Okay, so yes, I'm doing the integration by parts. Okay, to this. So I use the usual steps, finding my favorite u and my favorite dx, and then try to use this formula to find the answer. But then what I've done is basically I got this another one here, another integral here, which I have to solve again by integration by parts again. So I do that once again. So again, I choose what I like, which u I like and which dx. Okay, I calculate everything again using this formula again. All right, and then this is what I got: cosine x for x plus. Now I get this again, and then I realized that this here, okay, is the same as this here. Hey, so if I rewrite everything again, if I rewrite this again, all right, I rewrite this plus e sine x, which I got from here, minus, because I got minus here, okay, minus the whole thing here. So minus the whole thing here from here, and this one here from here. All right, plus c, of course, is an integration constant. Now I realize that, hey, these two are the same, so I can just bring this back to here because it's a minus. Bring that here, I got 2, and then I just collect everything here, sine x, cosine x, leave out the e to the power of x, and then I get this answer. So finally what I've done is I bring the 2 back in here, so I got the expression for the integral of e to the power of x sine x dx, which is this whole thing right here. This is nice. Okay, so I hope my point is, usually whenever you've got, so integration by parts, this is a conclusion, integration by parts. Okay, so let's say you've got a really messy function here, all right, and then you know integration by parts, the formula is u times v minus integration v respect to du. What you need to do, step 1 is find u and dv dx first, whichever you however you want to separate them, and then step 2, I guess, is find du over dx and also v from this, and step 3 is plug them in the formula, this one here. All right, and let's hope you find the answer. If you still left with the integral, you can repeat the step again. Okay, repeat if necessary, just like what we've done. Okay.